Okay guys, I'm just going to show you and tell you and inform you a bit about the battery that powers the RC Surfers, the Bro RC Surfers. Some of the other RC Surfers might run on nickel metal hydride or nickel cadmium batteries, but we use the lipo battery. It's 16.8 volts and it has 5,000 milliamps of power. The problem with these batteries are they can be quite dangerous. So when you charge these batteries, they need to be charged in a charging bag. You have the potential to explode if they've been mistreated or if they're old or been overcharged. So you also use a special charger. It's not an expensive piece of equipment, but it's a charger that actually manages the charging and balances the various cells. So as you can see, there's 1, 2, 3, 4 cells that make up this battery. Each cell is 3.7 volts. This little lead over here is what we call a charge balancing lead. This gets plugged into the charger so that when you're charging this, each cell will end up having the exact amount of volts. The reason why we don't supply this battery with the Bro is that most shipping companies, airline companies, won't permit just anyone to ship one of these batteries. These batteries are relatively safe before they're activated, before they're fully charged, and the companies that manufacture them and distribute them do have a certification to be able to ship them as safe. But once you and I have been using this battery, it becomes vulnerable, and these batteries could actually explode on a flight and cause an entire plane to crash. So we don't want that. So when I sell a Bro board, I'll give you a link as to where you can acquire a battery, and most of your hobby shops and all your online suppliers have these batteries and have them shipped to your door. So what I want to show you guys today is how best to prevent this battery from being damaged when it's in your RC Surfer or RC Bro bodyboarder. And the first thing you need to realize is that you're operating this battery in the salt water environment. This battery is made out of aluminium, salt aluminium, and then when we're dealing with current, we have a process called electrolysis, which can be very corrosive. And if water happens to get in the back of this battery over here, you can see it's got a plastic sheath over it, a shrinked sheath. But if water gets in over here, salt water, or it gets down in this opening over here, or in the top opening over here, and if it gets down into any of the terminals, eventually those terminals, well, I wouldn't say eventually, because quite quickly after a third or fourth charge cycle, those terminals will corrode because of the current that's flowing through them and accelerates the corrosion process. And before you know it, your battery will be ruined. It's one thing with the battery being ruined when it's out of the board, but what you don't want is for your battery to fail when you somewhere 300 yards offshore in a strong offshore wind condition and your battery dies. It might just end up that you end up losing your entire board, being blown out to sea. So as my grandfather always said, prevention is better than cure. So I'm going to show you just a simple but effective way on how to seal this battery so that it doesn't have any corrosion taking place inside of it. And what I use the basic duct tape, a bit of insulation tape, and I don't know what they call this overseas. Some guys have said you call it blue tack, but this is a product that we call Prestick. You use it to stick posters onto the wall, etc. It's like a type of a gooey, I suppose you can call it a putty. It's a tacky, stretchable product. Okay, and this is what we're going to use as well to ensure the seal on the battery. So the first area that's the easiest to seal, we're going to seal the back area. Just peel off a bit of duct tape. Fold these in nicely. Guys, be sure to do this. When you get your board, you're all excited and all you want to do is get it in the water. But I promise you, there's nothing sadder, I'd imagine, than seeing a board being blown out to sea because you were just too excited to prepare your battery adequately. Besides the expense of these things. Okay, so there we have, that's duct tape off. Let's find the start of our insulation tape. stretch your tape around nicely. Okay, that took all of a couple of seconds. You can see there, and that's all nicely sealed off now. No water's going to get in there. This area in the board is actually the area that's close to the coupling, the rotation, and we always get a little bit of moisture after a few runs finding its way up the drive shaft, spraying around this. So you want to make sure that that is nicely sealed off there. Now we're going to move to the other end. We're going to first of all use the just going to cut this plastic a little bit here so our cables can lie forward a lot easier. So first we're going to squeeze in that press stick around these areas over here to make sure that it's really sealed nicely. As you can see there, let's seal that nicely there. Just going to wind a bit of tape around you quickly to keep that there. So you can see there the balance leads are nicely sealed now with this tacky press stick sealing it off. Again, we're going to use our trusty duct tape. You can hear the pitter-patter of the rain on my workshop roof. It's so welcome. We're in a serious drought in Cape Town, like you guys have been in California. I reckon we're going to run out of water in the summer months, so our daily prayers for a bit of rain. So that's sealed with the duct tape. Now I'm just going to neaten it up and add to the seal with insulation tape. Okay, and there we have the back end sealed up nicely. Balance lead, power leads. Some people will say if you ensure that you never get water in your board, you don't have to go through all this trouble. But as I say to people, I've been driving a car for well over 30 years now. Can't say I've had an accident, but I always buckle up. Prevention is better than cure. You could have numerous things happening. You could have, you could forget to tighten down your hatch cover. You could have a one of the water cooling pipes pop on you. You could have a seal on a motor pop on you. You could have your ESC water cooling pipe leak. I've known that to happen. You could just have been lazy and not bothered to grease up your stuffing tube and have excessive moisture come through. Numerous things, eh? Seal your battery. Takes all of maybe 20 minutes collectively, and you'll be sure to have a reliable, functional, long-lasting lipo battery that'll give you plenty of fun to have some amped sessions. Something else to add to the battery discussion. When I supply the BRC Surfer, there will be no battery connecting plugs on the actual electronic speed controller. The reason for that is usually every battery manufacturer uses a different type of plug at the end of the battery, and you've got to make sure when you order your battery that you have the suitable plug to solder onto your ESC. My advice to you is always go for a plug that has the biggest size terminal. With regards to RC boats in general, the actual amp draw on acceleration and in the turns is far greater than any of the other models. So there's huge power being drawn through these leads. Also, when you are soldering on the plug to your ESC, try and make sure that you run as shorter power cable as possible between the battery and the ESC. That just reduces the heat built up in the resistance of this wire length, which will protect the capacitors in your ESC as well as your batteries. You can see over here, we had a discussion not too long ago, myself and Larry Howlett. I usually use the XT90s. They're the bigger cables, but what I have been having a problem with, if I can just scratch around here. Right, so with the battery, you might end up, you'll end up with a different type of plug. These are the XT plugs. This is the XT60. I can't remember what this is called. This is also quite an okay plug. You can see it's got a nice big terminal size. This Dean's plug, actually, the manufacturer put this little Dean's plug on this battery. I mean, look at the size of the wires, and then they put this little plug on here. You can see the contact areas are almost ridiculous. Okay, and that's just going to generate so much heat on that joint there. One of the things I struggle with the bigger XT90 plugs is two things. The one is, you can see here the terminals there, they've got a split in them. So sometimes what happens, that male terminal gets thin, and when you marry it with the female terminal, it doesn't always make good contact. So often you've got to shove something in the center here to keep it open. I also find when this terminal gets dirty like it does from corrosion, we're operating in a salty environment, very difficult to clean it. And that's very important that these terminals remain clean, because if they're dirty, builds up heat and you can actually have your plug area melting. So what I'm running here now, these are called gold bullet connectors. These are actually 8 mil in diameter. I think they're the biggest you get, and they're definitely, as you can imagine, going to give me the least amount of resistance when they're plugged into the reciprocating ESC connectors. So that's that, Sessions. Hope you guys enjoyed that. Feel free to ask me any questions in the comments below.